2, 1.
Good morning everyone. Welcome to the class Easy Hai Online Learning Easy Hai. My name is Mahima Agarwal and I am your mathematics educator. So class, as we have discussed in the last class, our series of questions based on the chapter circles of class 10th. So today we will continue the series. As we have completed 2 questions in the last series, so today we will start it with my question number 3. And now you have to look at the questions and their solutions as well very concentrately. Okay, so let's begin.
2, 1.
Good morning everyone. Welcome to the class Easy Hai Online Learning Easy Hai. My name is Mahima Agarwal and I am your mathematics educator. So class, in the last class we were discussing chapter circles of class 10th and we have discussed all the theorems and some questions based on it. So now we will continue the series and we have discussed 2 questions. So today we will continue it with my question number 3. So I hope you all are focused and ready to understand what we will learn today. So let's start. So let's come to the question number 3. The question number 3 is saying that there is a figure in which PA and PB are the tangents. It is clearly visible that PA and PB are the 2 tangents to the circles drawn from an external point P. Obviously, all the tangents are drawn from the external point, so that external point is P. Now, CD is the another tangent, that is CD, which is my third tangent touching the circle at Q. It is touching the circle at point Q. Now, if PA is equals to 15 centimeter, okay, this quantity is given that PA is equals to 15 centimeter. Now, what is the perimeter of CPD? We have to find out the perimeter of this triangle. Is that clear? I hope question is understood. No doubt in it. Only one quantity is given over here, which is PA is equals to 15 centimeter. So we have to find out the length of CPD, means this complete triangle. Clear? So before I start solving it, you recall the theorem in which we learned that from any external point, if there are 2 tangents, then the length of the tangents are equal. Clear? I hope it is remembered to everyone that the length of the tangent is equal from an external point. So how many tangents we can say? From point P, here PA is my one tangent and PB is the another one. From point C, there is a tangent CA and CQ, and another tangent from point D, that is DQ and DB. So let me write all these tangents which are equal to each other. Number 1, PA is equals to PB, okay, and it is given that the length of PA is 15 centimeter. That's why I can say PB will also 15 centimeter. Clear? Now second, from point C there are 2 tangents CA and CQ, correct? I can write CA will equal to CQ. We don't know what is the length of this, so I'll mark it as equation 1. And the third tangent from point D, there is DQ is equals to DB, right? So DQ is equals to DB. So again I don't know what is the length of it, so I will mark it as equation 2. I hope this is clear, what all the tangents are equal to each other. Okay, now come back to the question again. We have to find out the length of CPD. CPD, this one triangle. So I can break it in some parts, like length of CPD length of CPD can be written as length of PC plus CQ plus QD on plus DP. Clear? Can I write it like breaking it? CPD is equals to PC plus CQ plus QD and plus DP. Correct? Now we have just written that CQ is equals to CA and DQ is equals to DB according to the equation first and second. So can I replace it? PC plus, at the place of CQ I will write CA and QD is equals to DB. I can write DB and DP will remain as it is. Okay, by equation by first and second. Is it clear to everyone? Now just look at this PA and PB. Can I write PA is equals to PC plus CA? PC plus CA? Yes or no? Obviously, because I am just breaking the length. It is whole complete to the PA. And similarly, PB is equals to PD plus DB. Right? So here I will use this. PA is equals to PC plus CA and DB plus DP. So I will write it is equals to PA and it is equals to PB. Clear? Now what is the length of PA? 15 centimeter, and what is length of PB is 15 as well. It means 15 plus 15, hence it is 30 centimeter. I can say that length of PCD is equals to 30 centimeter, and this is my required question. That what is the length of PCD? It is equals to 30 centimeter. Okay, do you understand it? I just applied only one theorem, that is, from any external point of the circle there are two tangents and the length of these tangents are equal to each other. Clear class? So this is a one kind of question. I hope you understand it. It was easy to solve. So now we will discuss next question.
3, 2, 1.
So class, now my question number 4. So in the question number 4, it was asking that in the given figure, xy and x dash y dash are two parallel tangents. It is given that xy and x dash y dash are the two tangents which are parallel to each other, and to a circle with center O. The center of the circle is named as no, and another tangent AB with point of contact C. There is another tangent AB which is cutting the xy at point A and x dash y dash at B and touching the circle at point C. Clear? Now, right. Now you have to prove that angle AOB is 90 degree. Clear? We have to prove that this one angle is 90 degree. Clear? So this is my proving statement, and the given statements are just that that xy and x dash y dash are parallel. So let me write that given xy and x dash y dash are parallel. Okay, this is one statement which is given in the question, and we have to prove angle AOB is equals to 90 degree. Clear? So you understand the question. what it is asking for and what all the quantities are given in the question. So let's start. How can we prove it that this is 90-degree angle? So just think about it. This is a triangle AOB. If I prove that this angle and this angle, the sum of these two angles is 90-degree, then I will be able to prove that this one angle is 90-degree, because sum of the remaining two angles should also be 90-degree, correct? So how can we prove that these two angles are 90-degree? So first of all, I will construct something, that I will join the line OC. I will join points O and C. So there is a construction. What I have done, join points O and C. Clear? When I will join the point O and C, there is now two triangles, triangle AOC and triangle BOC. Now take the triangle POA and in triangle AOC. Clear? I will prove the congruency in triangle. Let's start the solution. Okay, I will take the triangle in triangle POA and triangle AOC. Correct? I'll take in these two triangles, right? Now just look at the triangles. One is from the point A, there are two tangents, PA and AC. Correct? There are two tangents, AP and AC. These two will be equal by the theorem that the tangents from any external point are equal in length. Two tangents from same point. Clear? That's why they are equal. Now another point is OP and OC. These two are the radius of the circle. OP is equals to OC. These are the radius of the circle. And the third one is OA. OA is common in both the triangle. So I can say OA is equals to OA, which is common. Now I have been proved by SSS. These are three sides of the triangles. So by SSS congruency, I can say triangle POA is congruent to triangle AOC. And when the triangles are congruent, their corresponding parts are also equal. So I can say, if I named it as number 1 and this number 2, so I can say angle PAO will equal to angle CAO. Angle CAO by CPCT. Clear? In short, I can write angle 1 is equals to angle 2, so that you will not confuse with the angles. Clear? So as we have proved in this triangle, similarly prove in these two triangles, in triangle OQB and in triangle OCB. Right? When I will take these two triangles, then this angle will also equal to this angle. Clear? If I name them as 3 and 4. Okay, so I will write like similarly. I will write over here like similarly angle 3 will also equal to angle 4. Let me give it a name, equation 1, and this is equation 2. Clear? Just keep it in mind that angle 2 is equals to angle 1 and angle 3 is equals to angle 4. Equation 1 and equation 2. Okay, now again come back to this triangle. what is happening that I have to prove that angle 2 plus angle 4 is equals to 90 degree. If I'll be able to prove it, then I can say that this angle is 90 degree again. Clear? So just take one relationship between it. In angle PAB, just see angle PAB and angle QBA. Angle QBA. When I will add these two angles, it will make 180 degree. Tell me how it will possible that the sum of these two angles will be 180 degree. Why? Because they are the co-interior angles. What are these angles? These are co-interior angles. That's why the sum of these two angles will be 180 degree. Clear? Now angle PAB is what? Angle PAB is angle 1 plus angle 2 plus angle 2, and angle QBA is what? Angle QBA is what? Angle 3 plus angle 4, right? Angle 3 plus angle 4, correct? It means it will be equal to 180 degree, and we have just proved that angle 1 is equals to angle 2, means I can write it 2 angle 2, and here I can write it 2 angle 4 is equals to 180 degree, means angle 2 plus angle 4 is 180 degree. Yeah, that is what I have to prove, that angle 2 plus angle 4 is, sorry, it's 90 degree, 180 by 2. So it will be 90 degree. Now I can say when the sum of angle 2 and angle 4 is 90 degree, then the remaining angle of the triangle is also 90 degree. Okay? So now I can write that in triangle, I'll write over here, in triangle AOB, when angle 2 plus angle 4 plus angle AOB will be 180 degree, according to the angle sum property of triangle, I can say it is 90 and angle AOB is equals to 180. So angle AOB is equals to 180 minus 90 is 90 degree. This I have to prove. Clear, class? So this was the proof of the question. What we have done, we have applied only one property of triangle, in which I have proved that the sum of these two angles will be 180 degree, because these are the co-interior angles. Clear? Nothing else was done over here, because usually we done the congruency part and proved two angles equal to each other, and then just a one trick over here, that we have proved two co-interior angles. Clear, class? So this is how we come to the conclusion that angle AOB is equals to 90 degree. This was the one approach of this question. So this is how you can do the questions, and also come to the thing that what will be the thinking process to come to the solution. Just like I have think about it, that if I prove this angle 90 degree, I have to prove the sum of these two angles 90 degree, and proving them 90 degree, I have to prove these angles should be equal to each other. So step by step we come to the solution. Okay, so I hope you understand this question. Now let's come to the next question.
2, 1.
Okay, class, now come to the question number 5, and it's a tricky question, so we will look at the question very focused. Okay, now the question is, prove that the parallelogram ABCD is a parallelogram. It means that it will follow all the properties of the parallelogram, right? Now we have to prove the parallelogram circumscribing the circle is rhombus. It is a parallelogram. It is proved. But I have to prove that it is a rhombus. So there are some basic differentiation between rhombus and parallelogram. So focusing on the properties of the rhombus, we have to prove that ABCD is a rhombus. Correct? You understand the question? Since the rhombus has all the sides equal, rhombus has all sides equal, right? And parallelogram has opposite sides equal, right? So if I prove that these sides like DC is equal to DA, if I able to prove that DC is equals to DA, then I'll be able to prove that it will be automatically equal to the other sides also, right? Because it is a parallelogram. That is how I can say that DC is equals to AB. I can say that it is a given statement, DC is equals to AB, and similarly DA is equals to CB. So if I prove that DC is equal to DA, then it will automatically equal to AB and CB also. Correct? So just keep in mind that you have to prove that DC is equals to DA. What we have to prove? This. To prove DC is equals to DA, and these two are the given statements since it is a parallelogram. Clear? Now come to the tangent part. Since there are many tangents from other points, like from point C there are two tangents, CR and CQ. From point D, DR and DS. From point A, AS and AP. And from point B, BP and BQ. These are the tangents from 4 different points. Now, according to the theorem of the tangents, from an external point, there are 2 tangents and the length of these tangents are equal, right? So I can say, that CR is equals to CQ from tangents from point C, right? Similarly, DR is equal to DS again. Next, AS will equal to AP, same reason. And last, BQ is equals to BP, right? I hope you understand. It is just by the theorem. This is by point D, this is from point A, this is from point B. Okay, these are the equal tangents from different points. Is it clear to everyone? Now we have already know that DC is equals to AB. DC is equals to AB, correct? And DC is what? DC is DR plus RC, right? DC is what? If I'll write, DC is equals to DR plus RC, and RC is equals to what? CQ. RC is equals to CQ, and DR is equals to what? DS. DS plus CQ. DS plus CQ. Since these two lines are already equal, DA is equals to CB, right? So I can say that this DS is equals to QB, correct? So I can write QB plus CQ, means QB plus CQ, and it will be equal to CB. Hence, it will be equal to CB. So, starting from DC, I came to the conclusion that it is equal to CB. I hope it is clear. What we have done, I just break the DC. It is equals to DR plus RC, right? Now, RC is equal to CQ. We have just write that they are the same, they are the two equal tangents from the same point. That is why I write RC is equals to CQ. Now, DR is what? DR is this part, which will be also equal to DS. This will be equal to DS, this part, because according to this theorem. Now, DS is equal to QB. Why? Because DA is equal to CB. These are the opposite sides of the parallelogram. Correct? So, I can write DS as QB, and QB and CQ makes CB. Now, I can say that DC is equal to CB, and similarly, I can say DC is equal to DA, or CB is same equal to each other. What we have to prove over here, that DC is equals to DA, since DA is equals to CB. That's I have proved over here. So, by equation, I can say DC is equals to DA equals to CB and equals to the remaining line, that is AB. Clear? Hence, all the sides of the parallelogram equal, that is why it is rhombus. Since all sides are equal of parallelogram ABCD, so I can say that ABCD is a rhombus. Clear, class? Is that clear? Now I have just proved that the ABCD is a rhombus. I hope you understand it, how we have done it. I just took the property of the tangent, that the tangent from the external point drops an equal tangent on the circle. That is why I break the lines and then apply the rule that parallelogram has equal opposite sides, and continue solving it. Then I came to the conclusion that all the sides of the equal of a parallelogram, then ABCD is a rhombus. I hope you understand it, and this is a one kind of question. It can be converted, like if it is given rhombus, you have to prove that it is a parallelogram or not, or maybe any other figure. Okay, so this is how you can prove the questions. Now we will come to the next question.
2, 1.
Okay, class, now move to the next question, question number 6. In the question, there is a figure given. In the given figure, PQ is a tangent. PQ is a tangent drawn from an external point P. This is my external point P, and it is touching the circle at point Q. Now, the center of the circle is O, and QOR is a diameter. It is clearly visible that QOR is a straight line, and it is diameter of the circle, where length of QOR is 8 centimeter. It is given diameter is equals to 8 centimeter, such that angle POR is 120 degree. The angle POR, this is giving 120 degree. Now you have to find out OP and PQ, means we have to find OP, this one length, and PQ, this one length. Clear? Is it clear to everyone? The what we have to find out in the question? We have to find out length of OP and length of PQ. Second, what is given? That angle POR is given 120 degree. And one more thing is given, that the diameter of the circle. Diameter is given 8 centimeter. Clear? Since diameter is 8, then what will be the radius? Radius will be 4 centimeter. Right? And our diameter is QOR, then radius will be, I can say, OQ. OQ is the radius, means length of OQ is 4 centimeter. So just keep it, remember that OQ is equals to 4 centimeter. Now there is a theorem in which we have learned that when there is a tangent from an external point, then the shortest distance from the center to the point where it touches the tangent to the circle is perpendicular to the tangent. Right? It means this is perpendicular. OQ is perpendicular on, I can say, PS. OQ is perpendicular on PS. Right? OQ is perpendicular on PS. So I can say angle OQP. Angle OQP is equals to 90 degree. So in triangle OPQ, what we have now, I have angle OPQ which is 90 degree, and I have a length of OQ which is 4 centimeter, and I have to find out the length of OP and PQ. Clear? So now we have two quantities and we have to find out the two others. Is it clear? Now just take one another thing, that since QOR is a diameter, it means it is a straight line, and a straight line makes a straight angle. So if this angle is 120 degree, then what will be this angle? The remaining angle will be angle Q will be what? 180 degree minus 120 degree. Any doubts? Since QOR is a diameter and a straight line, that is why angle POQ is equals to 180 minus 120. It means it is equals to angle POQ is equals to 60 degree. Now one more quantity I am having, that this is angle POQ is equals to 60 degree. Clear? Now just now look at the triangle. This is 60 degree angle. This is my perpendicular. So if I am taking this angle, this will be my base and this will be my perpendicular and this will be the hypotenuse. Now apply the Pythagoras by the Pythagoras formula, we can find out the another quantity, but we are having only one, that is this one, that is OQ. Length of OQ is given 4 centimeter, and we have to find out the length of other two sides of the triangle. So we are given one angle. Have you learned about cos theta? Cos theta is equals to base upon hypotenuse, right? And base is what? Base is OQ and hypotenuse is OP, right? And theta is what? Theta is 60 degree. So cos 60 is equals to OQ upon OP, where OQ is given 4 centimeter. OQ is given 4 centimeter. We have to find OP, and value of cos 60. Value of cos 60 is 1 by 2. Using the trigonometric ratios, I applied cos 60, and the value of cos 60 is 1 by 2 is equals to 4 upon OP. I'll cross multiply and OP will equal to 4 into 2. It means is equals to 8 centimeter. Now I have value of OP also. OP also. Clear? Now one thing is left, that is PQ. So there are two ways to find out the length of PQ. One is Pythagoras theorem and second is tan theta. I can also apply tan theta over here. Tan theta is equals to what? Perpendicular upon base, and perpendicular is here PQ and base is OQ. The base is OQ and theta is what? 60 degree. It means it will be tan 60. Clear? We have to find out length of PQ. Length of OQ is 4 and value of tan 60. Value of tan 60 is under root 3. So directly I will multiply 4 under root 3 is equals to PQ. Hence I got both the length which are required over here. OP is equals to 8 centimeter and PQ is equals to 4 under root 3 centimeter. Clear? It can be also find out by using the Pythagoras theorem, because now I have length of hypotenuse and length of base, so easily I can find out the length of perpendicular by Pythagoras theorem. Okay, so you can apply and also and find out the value. You can do it by your own. Okay, so this was the easy question, but the simple trick was there that you have to find out this angle and then apply the cos theta. Otherwise you won't be able to find out the any term of them. Clear? So this is basically a trigonometric part, but you will come to know that what are the values of the these angles and the trigonometric ratios and everything. But here you can understand that cos theta is equals to base upon hypotenuse, and cos 60, value of cos 60 is 1/2. This is fixed. It will not change. Okay, there is no variety in this. So this is a one kind of question you have to prove in your examinations. Okay, circle is a easy chapter. You don't have to put many efforts into it. Very less theorems, not many properties on L and all. So you can easily solve the question if you know them properly. So I hope you understand. Now we will discuss the next question.
2, 1.
Okay class, now come to the question number 7. Just look at the question carefully because it is a very important question. It has been came in your examination before. So I will demonstrate the question. Question is, two equal circles. These circles are equal, having centers O and P. Okay, with center O and P. Touch each other at X. This is the point where these two circles are touching each other with center P at A. Basically, we are producing this line to touch the point A in the circle having center P. Right? Understand? Now, AC is a tangent to the circle. AC is drawn which is tangent to this one circle having center O. Clear? And at the point C, PD is perpendicular to AC. It is given that it is perpendicular to AC. Means this thing. PD is perpendicular to AC, and find the value of dP upon CO. Means you have to find out the ratio of dP and CO. This and this. You have to find the ratio of dP to CO. Clear? So what things are given, that this is your 90-degree angle. Since it is a tangent on the circle, so it will also be a 90-degree angle. Right? Thing is given that these two circles are equal. If this is the radius, is the center of the circle, then AP plus PX plus CO, this all makes 3R. Since one part of it is R, then the 3 part of it will be 3R. Right? So I will write it. Angle ADP angle ADP is equals to 90 degree. This is given. And another angle ACO will also 90 degree. Why? Because AC is a tangent on the circle. AC is a tangent. Clear? Now one more thing, that AP is radius. AP is the radius R. So AP plus PX plus XO, it will make 3R. Correct? Just keep it in mind, and I will make it my equation number 1. So you understand, this is my 90 degree angle, this is my 90 degree again, because AC is a tangent and then AP is a radius. So AP plus PX plus XO is equals to 3R. Okay, you understand all these points? Now I will take in triangle APD and triangle AOC. Okay, I will take in triangle ADP and triangle AOC. Kids, there is a concept of similarity. Okay, just this is a 1 point above the congruency. I have told you that two triangles are congruent when they completely overlap each other. Okay, if I put two triangles on each other, so it will not be able to look to see any edges of the another triangle. This is the congruency. But there is another concept, similarity. If you have learned about it, similarity is what? Similarity is something whenever we form a image, anything, like if I form a square and the dimension of it is 4, I assume that all the sides of this square is 4. Okay, so I can make a miniature of it. It means its measurement will be different, but its ratio will be equal, right? All the sides will be in the same ratio. This is called similarity. These two figures are similar to each other, and I call that the smaller one is the miniature of this original figure. Clear? So in case of triangle, when there are two triangles, I have to prove similarity in them. Let this is 1 and this is 2. Then I have to prove that angles are equal. If their angles are equal, then I can say that these two triangles are similar to each other. Clear? So again, I will prove the similarity in triangle ADP and in triangle AOC, because we are asking for the ratio over here. We are not asking to equate the sides, and whenever we equate the side, we come to the concept of congruency. But here we are asking for the ratio. So we will discuss about similarity. Okay. So in triangle ADP and in triangle AOC, angle ADP is equals to angle ACO. Why? Because both the angles is 90 degree, right? There is a one common angle, that is angle A. Angle A is equal to angle A, which is common. And congruency can be proved if I prove that all the angles are equal to the angles of the another triangle. If any two angles are equal to any two angles of the another triangle, since the angles of two angles of this triangle is equal to the two angles of this triangle, then I can say that the third one is also equal, because both the triangles will follow the angle sum property of the triangle, right? So I have to prove that any two angles are equal, and I have already proved that this is a 90-degree angle and this angle is common, means by AA similarity rule I can say these two triangles are congruent to each other. Clear? Similar to each other. Hence I can say triangle ADP, A and triangle AOC are similar to each other. When two triangles are similar to each other, then the ratio of their sides are equal. Okay, it means I can say AD upon AC is equals to AP upon AO and is equals to DP upon CO. Clear? By the similarity I can say that the ratio of the sides will be equal. That's why I write AD upon AC is equals to AP upon AO and DP upon CO. Clear? Okay. Now one thing I have written here, that AP plus PX plus XO is equals to what? 3R. And here I have write that AP upon PO, AP upon AO, sorry, this one. Okay, so I have to find out the value of this. So can I take this one part? If I will solve it, then it will be also equal to this. Then AP upon AO, AP plus PX plus XO, it all makes AO is equals to AP plus PX plus XO is equals to what? 3R. And AP is what? AP is only 1R. So it will be R upon 3R. Now I can say it is equals to 1 upon 3. So I can say it is equals to 1 upon 3. Now DP upon CO will also equal to 1 upon 3. Hence the value of DP upon CO means the ratio of DP and CO is equals to 1 upon 3. Clear? I hope it is clear to everyone. Kids, whenever you see any question in which you are asking for the ratio, you always come to the concept of the similarity, because in a case of similarity it happens that when two triangles are similar, then their ratio of their sides will also equal. Okay, I hope you understand it, and this is some kind of important question, so you can mark it important. This is important one. Okay, so some more important question I will take in the next class. This is done for today class, and I will also discuss some various approaches of the each and every question, and I will also give you some hints so that you will go and find out that what all the methods to solve the questions. Okay, so a new concept we have learned, that is similarity. If you want to learn about it more, I will give you a different class for this, for all the concepts of similarity in one class. Okay class, so till then you have to practice more to learn more about it, and keep on practicing the mathematics. Okay class, take care, bye bye.